Hey everyone, I'm Matthew. I'm really happy to be back. Thank you all for allowing me to come back yet again. It's good to see some friendly faces and names. If you're not sick of me by now and you're interested in getting in touch and finding more content, oh, that screenshot has, well, it might that QR code might work. You can find me on LinkedIn at Matthew L. Hess. You can find me on YouTube at C Sharp Artisan. Got a whole bunch of videos there. It would be lovely if some of you would watch them and subscribe. And you can email me, csharpartisan@gmail. The lightning talk, so let's get moving. We're going to be talking about cooperative cancellation. And I know that sort of sounds like you and a bunch of your friends were planning to go get a beer and you all got together and decided not to go. That was cooperative cancellation. And it's similar to that. Okay, it's a C-sharpy way of kind of doing that. So what is cooperative cancellation? Cooperative cancellation happens when you have a long-running process or processes, such as a thread or a task, and you want to tell it to please stop what it's doing. Just stop. Don't finish. Don't keep chugging. Please just stop. And you want to do it politely, but definitively, so that you can gracefully shut down a background process or a series of threads. It's the software equivalent of clicking start, shut down, and closing the windows, as opposed to just popping out the battery and pulling the plug on your laptop and just cold booting it. So I don't think you can pop the batteries out anymore, holding down the power key or whatever we have to do these days to do a really abrupt shutdown. So that's the problem we're solving. And you can hand roll this. And I've got a little video where we kind of talk about that. But what I'm going to show you today is kind of the standard C# approach to this using a cancellation token. And so the first example we're going to look at is a cancelable task, a simple cancelable task. Now, this task has in its heart a long-running loop, a while loop. And so here's what the code looks like, right? Public async static task execute. And we just pass in an ID so we can identify it in the log messages. And then we pass in a cancellation token. And now we get some logging, and we go into this long running loop, which basically means do this forever until I get this signal from the cancellation token that cancellation has been requested. And then because of the way this is written, it will just drop out of the loop and it will stop executing. So there's an example of a task wrapping a long-running loop that is cancelable. We're going to run that code here in just a second using this program. And all of my little sample programs kind of look the same. I'll just execute it. And what you can see is we have a little menu of things we can do. And the first item, if we select one, it's actually going to run a cancelable task. So I'm going to select one. And now it has started, and you can see it's looping. Every second, that while loop is just looping. There we go. Long-running task. And when we are ready to cancel it, I'm going to click enter, and this is going to signal it to stop. Are you ready? And there we go. So it stopped. We shut down our loop. So let's look at the code inside my program that does that, because when we select item one, we run this one, run cancelable task. So we create a cancellation token source. And here we are launching the task. And the little message, press enter to cancel it. And once you hit enter, this line executes, cancellation token source dot cancel. And that sets that flag. Easy peasy. There you go. Cooperative cancellation. Now, one thing you'll notice in that particular example with a loop is that it does have to complete the current loop. So if I select one and cancel right after, well, it's hard to illustrate it unless I really lengthen the time of the loop. I guess I could do that, and to really make this clear. So let's let it pause for 3 seconds. Okay, we'll bring this over. Okay, so now we have these slower loops. And I'll wait till it gets into loop 3 and hit enter. And did you see how the stop execute waited a couple of seconds? So that's just one thing to be aware of in this kind of polling loop, where the way it's constructed. There are ways around that, and we're going to talk about that. And there are other constructs like event wait handles and other things that can give you instantaneous stoppage. But depending on how you've done this, there might be just a little delay. So the next example is run several cancelable tasks. All it does, number 2, is it just starts 3 of these. So now they're all going to loop. I've got them staggered by a quarter second. So now they're all looping. And I hit enter, and they all stop. And what's nice about that is when we look at the kind of the control code there, is when we're running several, we stop them all with the same cancellation token source. Right? So you've got one master kill switch for everything. So that's nice. You don't have to go through and stop them all. Okay, so the next example of a cancelable task is one that is wrapping an HTTP call. We're actually calling, we're going to call HTTP client get async. So many of the .NET, of the async methods that are given to you through .NET libraries and NuGet packages, whether you're talking about the HTTP client or service bus or the SQL async methods, many of them have an override, a method signature that includes an optional cancellation token that you can pass in. So that means that what will happen here is not only will sort of our master function inside this task cancel if there's something that needs to, but it can pass it on. It can basically forward the stop signal to anything it happens to be awaiting. So this particular Azure function that I'm going to call, it's a little Azure function app that I have loaded up, and all its purpose is to delay. Like you pass it a parameter of delay sex, and it just doesn't return your HTTP call until it's done. So that's its mission in life. So what's going to happen here is when we call await client get async, this should await for 10 seconds before we get that log message. And what I'm going to do is I'm going to cancel it before the 10 seconds are up. So we'll run this code, and we're going to launch this long-running HTTP call. And before 10 seconds are up, boom, cancels immediately. Okay? So the await, which that's a whole other topic about how async await works and how it gets your signal, but that method supports the concept of using the cancellation token just to cut off anything that's awaiting, no matter where it is in its await, whatever's going on. So here is the the control code for that. Very simple. We launch the task, and it's the same, and we just say cancellation token source dot cancel. And the next little demo is to have 4 of those going. So, oops, you guys can't see my other screen, but there we go. So I've launched those. I will hit enter before 10 seconds, and all of them canceled. Just stopped on a dime. The last example I'm going to show you of using cooperative cancellation is with a thread. Now, thread-based programming has gone a little out of fashion. And in fairness, tasks do almost everything that native kind of C# threads can do. So for the most part, there's no reason, many of us don't have a reason anymore to implement threads. But if you're building your own like web server or something, kind of a framework, there are some things to be said for actually spooling up your own dedicated threads and just managing their full life cycles explicitly rather than through the task programming model execution kind of framework. So here is a cancelable thread. So if you're going to run a thread, basically you need to define a thread proc. Like, what is the loop? What is your thread proc? So here it is, and it's just called run. And you're going to have to call a delegate or pass in a delegate. So this delegate for running a thread can accept an object as its input. This is like C# 2. This is very early C#. So inside of this is where the actual thread loop is. And this is the thread loop, the long running loop. Now, in order to pass data to a thread, it is traditional to create a little class, which is the data that your thread wants on the input. So I'm just calling that thread start data. Our thread starts running and it casts the object to the proper type. And then it drops into a long running loop, which pauses for 1 second in the middle, and which will break once the cancellation is requested. So threading is fun. I actually have like a 10 video series on threading and tasks and background worker and just lots of different ways of approaching parallel programming. So if that's of interest to you, you can go find those videos. But for now, let's just run this little demo. So we're going to run a cancelable thread. And there it is. The thread is running and it's looping every second. And if I press enter, my thread will stop. And we can do number 6, which starts 3 threads. So there we have 3 threads looping. And whenever we feel like we've had enough of them, we press enter and they all stop. So there you go. Cooperative cancellation. It's something that you may have seen and wondered about. It's a really useful technique. And now you've seen it in action. Before we hand it over for our main presenter, any questions on that? We have like a minute.
No, no questions, but very cool. I didn't know that
Right on.
existed.
Okay.
All right, thank you, Matthew.